if you're not familiar with liquid staking networks on top of Stakehouse, definitely go to the docs. Docs at joinstakehouse.com, LSD. You'll be able to find out about what LSD, what that stands for, what it means, why it's built on top of the Stakehouse protocol, what benefits it gives you. And I want to talk about fees and MEV. So let me see if I can find a MEV staking pool. Right. So let me just try and see something here. So that doesn't work fine. No. Right. Okay. So I want to talk about an interesting piece of the puzzle here. So LSD is a factory for it's a collective and factory for Ethereum validators without the capital requirement that you normally need, of 32 ETH for setting up a validator. So that is skipping over like quite a few details here, but the key thing is that depending on the segment of LSD that you're interested in, either protected staking. So protected staking, on this side, that is to do with you want to accumulate DETH, and this side is you want to accumulate fees and MEV. So I'm going to go into these concepts. But the purpose of this talk is going to focus around this area, the syndicate. So the syndicate is important for the fees and MEV distribution within a liquid staking network. So within any given liquid staking network, there is a syndicate contract that will split all the network revenue that comes from either vanilla block building, 1559. You're talking about execution layer revenue, right? So any execution layer revenue for a given network will go through a syndicate contract in order to be distributed amongst all of the LPs that funded the fees and MEV part of any validator in that specific network. The node runners are getting 50% of the revenue that comes into the network, minus the DAO commission, and the fees and MEV stakers are the other LPs are getting the other 50% of the revenue, and that gets just distributed. It doesn't matter on so these like gray boxes here that is the perimeter of an LSD network, but you can write strategies outside of the network that will bring ETH in, and liquidity providers that want to share off either on this side. You want protected staking, you want that additional yield that you get from a DE token, which I'm going to go into in a second, or you're going to maybe write additional strategies for trying to get easier and more fair access to fees and MEV. So MEV becomes programmable at a token level. And sort of comes out of the dark forest really, and really allows people who don't have the access to like 32 Ether to get maybe a share of the network revenue. So before I go into any more details, I'm conscious about not assuming any knowledge of the underlying Stakehouse protocol. So liquid staking derivative networks is a tooling built on top of the Stakehouse protocol. So the Stakehouse protocol is an inventory management protocol for staked assets on the Ethereum consensus layer, and it allows you to mint debt positions on the execution layer against your staked position. You think of it like a CDP. You can mint DAI against ETH, right? But here, we're not minting DAI. Here, at the protocol is allowing users to mint debt positions on their staked assets, only at the point where the staked assets have reached an important checkpoint on the consensus layer, which is the activation eligibility epoch. So if I go onto the beacon chain specs, I'm definitely not a robot. Okay, let me just go onto the beacon chain specification. So phase 0 is fine. Right, so we have this epoch. So every validator has a number of key checkpoints. So in terms of when is this reached, there might be some nice context here, right? So if I go to the Stakehouse docs and we look at this the flow. So this flow, you can also apply it to the general deposit flow for the deposit contract. Because Stakehouse is just a wrap around the deposit contract for registering deposits. It doesn't keep any ETH, it just fires it straight there and registers the deposit here, right? So the general flow for setting up a validator, you're going to generate your keys. Here we refer the Ethereum CLI. That's quite old school now, but people are using Wagyu and whatever other tools now for doing this. It's very automated. You can use like what's called ChainSafe they've got libraries for generating BLS keys, so you can automate it very easily. And we you can find that we can give out the BLS key generation package. It's quite easy to do. You generate your keys, and then what you do here with Stakehouse flow, when the ETH is fired to the Ethereum deposit contract, the validator is registered as I was saying. So ETH goes into the deposit contract, and as long as the data is valid, right? So the data going into the deposit contract will be these things. So it'll be the BLS public key, it's going to be the withdrawal credentials, and there's also a BLS signature that goes into the deposit payload. So that happens on the execution layer. The deposit of so you can deposit 1 ETH into the Ethereum deposit contract, but until 32 ETH is sent, it will not actually register and set up a validator on the consensus layer. But when it does, it will assign it will assign all these values. So what it first will do is when all the security checks have passed, the BLS key signature is valid, etc. It will then say, right, okay, everything looks valid for this deposit. We can register a new validator to the network, and we will append it to the append-only list of validators. So that will assign an activation eligibility epoch. That is the epoch at which, as it says here, criteria for activation were met. It does not mean that the validator is active yet. That's very important to state. The validator is not active. It will activate at this activation epoch. What happens after that is, anything could happen. It could get slashed, it could voluntarily exit, and that's when all these other epochs are set. But at this epoch, it was eligible for activation. And at this epoch, it will activate, which will mean that it means a few things. It means by the time the activation epoch reaches, that validator must be so the file should be injected into a node, and the node should be ready and synced to perform validation duties. That will be attestation and block proposal at a basic level, but there's other duties that the validator can perform. So it's from this epoch when it needs to start working, and it is this BLS public key that will it is this BLS public key that's going to receive the inflation rewards, right? But the reason I'm talking about this is because the Stakehouse protocol allows you to mint your debt position only when this is reached. So this activation eligibility epoch, not before, right? So so the Stakehouse protocol, you think of it like as a router to the Ethereum deposit contract. It will route the ETH and send it to the Ethereum deposit contract, but it will not mint a token. It will not mint a single way of a token until this specific epoch has been reached. That is why we call it a deposition against it. So the consensus layer has certified that the deposit has reached the consensus layer from the execution layer. All the security checks are valid. all that stuff. And we allow this minting from this point onwards. That's the Stakehouse protocol, and you can read about it in the you can go to the Blockswap network security, and you can see the audit reports from runtime that go into more details about that. But the key thing here is that it is not yielding or not performing duties until this activation epoch, right? So that information will come in handy later, but this is when you can mint. So when you mint derivatives, the 32 sort of units of ether that went into the Ethereum deposit contract come out as 2 tokens at the base level in the Stakehouse protocol. So on one side you have DETH, and on the other side slot token. That is in a ratio of 3 to 1. There's 24 DETH and 8 slot token. And they serve different purposes within the protocol. The DETH, think of the DETH as a consensus layer, a tracking asset, and a slot is more of a execution layer tracking asset. So DETH, the 24 units of DETH receive all of the inflation rewards from the 32 ETH effective balance of that validator. So the 32 ETH worth of the rewards gets redirected completely to the 24 DETH. That means that the 8 slot token is not receiving any inflation rewards whatsoever. The slot is not. So slot is not receiving any inflation rewards. DETH is receiving everything, inflation rewards wise. So naturally, when it's receiving 32 ETH worth of inflation rewards on the 24 DETH, that's going to boost the yield to 33% on its own. The slot token, the 8 slot units, so slot serves 2 purposes. So slot is the flashable asset in the protocol. So the protocol is permissionless. Any validator can join and leave anytime, and that has to come with some level of accountability, and that is reached through the slot token. So the slot tokens are flashable. There's no contagion between these two. When a slot is being slashed, the DETH is not being slashed. And slot can be topped up to when the node, when the issues at the node level, assuming it's not like a violation of any of the consensus layer rules, assuming that is not happened, and it's like a simple leakage, maybe it's been leaking for a month or whatever. If the node issues get rectified either by itself or through the common interest protocol, the decom, and then when it comes back online, the slot can be topped up and business can continue as usual. Any DETH any consensus layer inflation rewards that are accrued on the and swept into the Stakehouse protocol, those are protected and not slashable. So that is a key distinction here. Now, what we want to focus on here is slot is there. It is a slashable token, but it's also focuses, as I said before, on the execution layer. So execution layer wise, the slot token is eligible for all of the MEV and network revenue on the execution layer. You're talking tips or blocks produced with MEV boost. The slot tokens are eligible to receive any of that revenue that happens on the execution layer. And because they are tokens that are they're fungible tokens attached to a validator. It makes the MEV incredibly programmable. So from an LSD perspective, I'll go back here. From an LSD perspective, you can coordinate liquidity providers of ETH in any way you want to get that to pull the ETH in such a way that when revenue is received in the liquid staking network, the syndicate contract can be used to distribute that to all of the LPs. If you are a giant LP provider, for example, the good thing for you is it's ETH in and ETH out. So ETH goes in, it contributes to the 32 ETH required per BLS key to set up a validator. and then you get pro rata share of the network revenue that comes out, minus commission that the DAO sets when they deploy the liquid staking network from the LSD factory. Some networks won't have a commission, some will. So that's up to the individual networks. Just to go into slot tokens into a bit more detail. So we have here sort of more details on what's going under the hood in slots. So we have this DE part, like well versed, and that's quite straightforward to understand. That's inflation layer from consensus. This execution side for slot tokens, the slot is split 50-50 in two ways. So for slot goes basically when the derivatives are minted, for slot is free floating, i.e. liquid, and can be and can go into the user's wallet. They can if they are just a solo staker or a Stakehouse, that'll go straight into their wallet. And the other 4 is collateralized in the protocol that will take the slashing. Now, all 8 is slashable, but this one is particularly, this one is the target initially for the slashing that is received, and when the issue is corrected, like I say, it can be topped up. So this can handle any amount of slashing because of the top up that is always there. There are a number of interesting things associated with that, with regards to the relationship between these. Well, I've gone through the relationship between them, and how it affects things like the redemption rate of a house. So that is to do with redemption rate and payoff rate of the house is like, how efficiently is a house performing? If you've got some nodes that are off, some node or validators that are offline, originates at a node level, but when you've got some validators that are offline, then those validators are going to get slashed in the protocol. The reporters work in isolation. Reporting is permissionless, and that will reflect in the efficiency of the house, otherwise known as the payoff rate, right? So at a house level, it is easy to see that the house is not performing efficiently, and so the aggregate value of the derivatives being minted from the house aren't as valuable as other houses. But how does this relate to the syndicate? You might be wondering. So if I go back to the LSD mechanism workflow, so every validator that is being registered in the consensus layer requires a 32 ETH deposit, either individual deposits or a lump sum. Stakehouse protocol only sends one transaction of 32 ETH once the validator is ready to be registered. And LSD is a way of accumulating that ETH and trustlessly inside of a network, right? So you have these protected staking depositors. They accrue the 24 ETH per knot, so per validator, and will get ETH in return. You can stake like 0.01 or something like that. So the LPs can come from anywhere and can be they don't have to be very big. So that's 24 ETH per validator. Another 4 ETH comes from the MEV stakers. So the MEV stakers will jointly supply 4 ETH per validator, and then finally node runners put up 4 ETH. There's you can't put any less than that. It's exactly 4 ETH. And it directly maps onto the slot tokens here, right? So the collateralized slot is the first to take on the impact, but also it also has exposure to the MEV rewards, and it has as well management rights of the validator, so easy access to the signing key, and ability to remarket the block space and all these sorts of things. The free floating slot, as we call it, or SE. Which is related to a specific house / like LSD, that is just that receives the revenue as well, but it doesn't have like all the management rights associated with the validator. So 4 plus 4, plus the 24 here, you 24, 4 and 4 here, that collects the 32 ETH required to go and register a validator. And as these two, so these two entities are entities that want to get exposure to, they don't want exposure to consensus layer inflation rewards. They want access to the fees and MEV, which can be anywhere between, like 0.03 ETH to 689, per block. It can be, it wildly varies. So they want exposure to that, but whereas the protected stakers, they want access to like 5% yield, fixed. It's low, but it's, it's steady from the consensus layer. And the guy that is helping distribute network revenue that comes into the network is the syndicate. So the syndicate is splitting 50% of the network rewards to the fees and MEV stakers, these 4 ETH per validator, and the other 50% here to the node runners. So in terms of like slot terminology, that's 50% to the collateralized slot owners and 50% to the free floating slot owners. So that gives you sort of a background and insight to what's happening really at the syndicate level. But what we wanted to do is actually drill down a bit further into what's happening in the syndicate to give you sort of more insight, because it's a really interesting area of MEV distribution that's extremely programmable and can produce some really interesting applications. So if I try and draw this manually, so we have a smart contract, we have a syndicate contract. This is 1 per LSD network. Let me see here. Do we have, let me try find money. So money comes into the syndicate. Right, so ETH comes in, right? Syndicate only receives ETH. Ether, right? And this can come from anywhere. This can be a block builder that pays to the LSD syndicate. It can be just a validator producing a local block. It can be the PON payout pool. It can be donations from anybody. Anybody can fire ETH to the syndicate. So the syndicate will receive ETH. Now, the ETH then is so the ETH is then split. The ETH is split 50-50. So we can have here like we'll have here a splitter, right? So this is what's happening internally inside the syndicate. So split the 50-50, right? So we do that, and then we put this into 2 buckets, right? So we have right. So we have 2 buckets, right? So we have fees and MEV LPs, wherever they came from, and then we have node operators. So the ETH then goes through this pipeline, right? So we have this inside the syndicate, this pipeline, right? So we split the ETH 50-50. So that goes here, 50% goes there, and 50% goes to the node operator in the LSD network, right? So, right, okay. So that's I would say that's very much a high level overview. That's and so it will get subdivided in a few ways. But one thing I want to do is actually say that with the syndicate, right, is in order to do that, the syndicate needs to be aware of the shares that are eligible to receive that, right? So you have all these BLS public keys, right? So let's just put here, we have BLS public keys, keys, right? So that are registered in the syndicate. The BLS key, BLS public keys, this is the native cryptographic identification for any validator on the consensus layer, right? So under the hood, so if we go back to the workflow, the LSD workflow, so, you have Alice and Bob. Alice and Bob might be giant LPs, and all they do is they're the simplest kind of LPs. They have ETH, and they know how to trigger a deposit function on a UI. They don't know anything about it, or what is a BLS key, what is a consensus layer, what is a validator. I mean, they might have high level understanding of it, but like maybe not low level understanding enough to like have a like if UI asks them, hey, put this BLS key here for a deposit, they may not know what to do, right? Unless say like maybe they have had some friend show them what to do it, and they use like friend delegation, right? But let's say for argument's sake that they're the simplest kind of LPs. So they're throwing ETH into the giant pool, right? Now the giant pool just says, yeah, I'll take ETH. And the giant pool allows any LSDN factory deployed liquid staking network to deploy this ETH to the consensus layer. Obviously deployed from the factory because the LSDs deployed from this can only use it for staking. Much like with the Uniswap, you deploy an LP pool from a Uniswap factory, then it will allow you to it will then serve the Uniswap UI and allow people to deposit liquidity and all those sorts of things. So the node runners, they're more technical entities. They are registering 4 ETH per validator per validator key that they present to the liquid staking manager. So they might come to the liquid staking network and say, hey, I want to set up like 10 validators. Here are the 10 keys, and the liquid staking network will say, yeah, that's great. 4 ETH per key, so please deposit 40 ETH. Right? Very easy. And they can then if they don't have the ETH to fund the other pools, they can just call on the giant pool and say, hey, can we feed some ETH into the network so that we can reach the 32 needed to do the deposit. Alice's capital gets utilized inside of the network, attached to a BLS key, sent to the deposit contract, and all that happens. Same for Bob. That gets mapped, but transparent to them.
Can I ask a question?
Yeah, please.
So, syndicate contract will get the MEV payouts, right?
Yeah, execution layer MEV. Yeah. Mm-hmm.
But it is related to a specific validator. But the syndicate takes a group of validator, right? Group of validators and split it among them. Mm-hmm. And this is within LSD, right? If I get it correct, the syndicate contract is deployed per LSDs. Yeah. In Stakehouse in Stakehouse it is like per house. The same thing, but just like LSD is a house too.
Yes.
So LSD validators are the one who is going to get the rewards on execution layer. What happens one of those validators has been slashed in the consensus layer?
Slashed as in they performed a consensus layer violation. Are they still part of the chain, or like you mean like a leakage or?
Yeah. So the thing is, you are getting an LP. You're getting an LP of a consensus layer validator BLS key. And you have tokens minted out of that. That's the slow token, right? And that slow token receive the validator's MEV payouts on execution layer. Correct? Is that what's happening? Correct?
Yeah. If you're recipient, yeah.
So one of that validator in the group, if the validator just become disqualified in the consensus layer, what's going to happen here?
Yeah, well, so they will be so the syndicate will allow so if you have been disqualified from the consensus layer, it is because Stakehouse protocol is a shadow ledger of the consensus layer, and its inventory in the execution layer is kept in sync with the consensus layer, then Stakehouse protocol allows anybody to report such an offense And that will basically notify the Stakehouse protocol that the validator on the consensus layer is no longer validating because it's ejected. And that propagates through the Stakehouse and anything built on top of it. So anything built on top of it includes the LSD, and that includes the syndicate. So basically, you can simultaneously poke the Stakehouse and the syndicate and say, yeah, this guy is no longer part of the consensus layer. But you can also you can do it if they're part. If they've left consensus layer, or if they're like inactive and they're leaking. You know, if they're suffering from an offline penalty, you can poke the Stakehouse layer and it propagates up the stack. You know, so if somebody's inactive and leaking, they've been active for a while. You can, you know, that slot will leak, right, as well. You know, because again, it's a mirror on what's happening with consensus now.
So what happens to the syndicate contract token that is representing the kicked or the ejected validator that has been reported to Stakehouse? Would they stop receiving any more funds?
Yeah. They isolated from the pro rata distribution of any ETH that comes into the syndicate.
Mm-hmm. So they will not be able to claim any further rewards coming in.
Yeah. I mean, historical rewards. Yeah, that's one thing that you know, whatever's earned up to the point you got kicked from the consensus layer. Yeah. That's fine, but you will no longer continue to earn rewards. And everybody inside of the syndicate, like everybody in the LSD network, you know, is part of the syndicate, and you're all incentivized to report such a behavior to the underlying Stakehouse protocol, because why should that, you know, that validator should, and the shares, right, the slot shares associated with it should not continue to accrue any ETH that comes into the syndicate.
Yeah, because they cannot provide any more payouts to the syndicate contract, so they are like futile anyway.
Yeah, exactly, correct. Yeah. So and on the other side, something that I was alluding to as well was, you know, like inactivity and leakages reported to the Stakehouse when the slot is leaking. Like, so let's say you're a node runner, you funded obviously 40 per BLFT that you registered, and that translates into 4 collateralized slot, right? So you have so given obviously this 8 slot, you've got 50% of the revenue that's come in. But if your slot is leaking for one or all of your validators, maybe you run all of your validators on the same node and the node is down, right? Then all of your validators are going to leak, right? Bad for you, because people are going to come and report that to the Stakehouse. And what the syndicate will do is the syndicate actually will self-adjust. So it self-adjusts and says, okay, Matt, you set up 2 validators, right? So you've got 8 collateralized slots in, you know, shares are registered to the syndicate, you know, so you have like pro rata based on that. But since people have been reporting that your balance is going down on the consensus layer, instead of getting when any ETH comes into the syndicate contract, you cannot, because you have less shares, right? So if you had 8 shares and then somebody reported across both your validator, you leaked 0.1 ETH on both of them, you know, your 8 shares are reduced by 0.2, right? So you're only 7.8 of those shares is going to actually receive rewards, right? You're going to be self-diluting, you know, until you fix your validator. And actually anybody can report that, but not only that, anybody can also top up that slot. So if let's put it like this. Let me do this. So right. Yeah. So let's say we have this syndicate and registered to the syndicate. Let's say we have this okay. So we have these 3 BLS keys that are registered in the syndicate. Each of them are run by like one node, right? Let's say this is node runner. Yeah. Okay. Yeah, these keys are run by node runner 1. node 102, node 103. Okay, so these are run by these three node runners. So if it's three keys, right? So they will have, so node runner one then will have like 4 slots. This one will also have, 4 slots to start with, right? Okay. 4 slots. So now that is a total of 12 slot shares for this side, right? This side of the equation is 12 shares, right? So just let's do this. Okay. In total, 12 shares, right? So this 12 shares on this side, right? So now, so this will be split, any ETH that comes into the contract, so ETH comes into the syndicate contract, it gets split 50-50. Right? It gets split 50-50, 50% to the fees and MEV LP, 50% to the node operators, right? Now, in our scenario, we're talking about like three node operators, each running one VLS key on their validators, right? So the 50% of the ETH that comes in goes there, and then it'll get split 3 ways here. But let's say this guy starts leaking, right? So we have a leaking that happens, right? So leakage takes place, and right. So slot before, 4 slots, and then afterwards 3.8 slots. Right. Okay, so this is the leaking that's taken place, right? Let me just I'll just label this. Right. So there were originally 12 shares split this way. This is now reduced to 4. And what happens is, the syndicate still says, well, in actuality, right, that slot, the slot that was leaked, 0.2, the thing about that is anybody can top it up. Anybody can top it up, right? So it could be the node runner. The node runner says, like, I don't know, the node runner goes on holiday, they lose power in their house, maybe there's a storm, or whatever the reason it is, right? So they lose, the validator goes offline, and they don't realize till they get home, right? So they don't try and remotely do like the IP recovery or anything like that to try and rectify the situation remotely. So they might come home, put the node back online. Anything can happen. SSDs go faulty, and then they self pop up the 0.2 slot, bring it back to 4, and then they would get like the full share of what's going on here. But maybe that doesn't happen. Maybe somebody else tops up the slot. In whichever way it happens, right? Whilst this 0.2 is leaked and reported to the stakehouse. So you report this, so leak is reported to stakehouse. The leak is reported there. The how much slot this node runner has is gone, right? Like lower. But there's still originally 12 shares, and that can be topped up, right? So what the syndicate has is it has a leak bucket or a spillover bucket, right? Whereby for any given BLS key, any ETH that comes into the syndicate that that is related to a slot that is not topped up will go into this bucket, ready to be redistributed to whoever tops up the slot. So what does that really mean in practice? Now, in the Stakehouse protocol, right? So you have, if I take this, okay, if I take this, and I take it to the drawing, right? So you have, yeah, we can resize it. So if we revisit what's happening on the slot page, all right, so you have the collateralized, and when the derivatives are first minted, the collateralized slot is assigned to the node operator. 100% of I'm going to call it C slot, right? So C slot, so that's just collateralized slot. So the C slot, so the collateralized slot, so that node operator gets 100%. Great. But so they're the only ones that are part of the vault. But okay, so there's somebody here, right? In theory, there's some entity, right? There's a node runner. So this is a node operator. If somebody else tops up that slot, any other account other than the original one, then top up user, right? Then that will get assigned the slot balance, right? So let's say that the node operator never topped up the slot. Maybe they correct the issue at the node level. But somebody else tops up the slot and corrects the loss of earnings, right? It corrects the loss of earnings that have taken place. Because obviously, when the node goes offline, the it's not yielding anymore, right? So the D is not slashable, but it's cannot continue to grow. So there is a loss of earning, right? That needs to be topped up. So if that happened and the node operator didn't top up, this one would have 3.8 slots. This is collateralized slot owner number 1, C slot owner number 1. And this topped up user would be they would own 0.2, C slot owner number 2. So when it comes to distribution, right? So let's suppose that during the time when slot was not topped up here, right? ETH came into the syndicate. So ETH could come in, let's say it was 1 ETH, split 50-50, 0.5 would go here, 0.5 would go there. Then it would get distributed by 12, but it can allocate the ETH here, here, and then here. When it gets to here, it actually allocates. So, if it was 0.5 ETH, it would get divided by 12 first, and then multiplied by the balance of the collateralized slot owner. So for this node owner, it would be times 4, but then for this one would be times 3.8, with the amount for the 0.2 that's not topped up going into the bucket. And when this user tops up the slot, they can actually claim the ETH that was accrued in the leak bucket, right, for this topped up user. So they can, because the ETH is allocated, all 4 of it is allocated to this BLS key, but the original node operator can only claim 3.8 ETH out of the 4, like pro rata share of the ETH that came in, and the user that tops up can claim the ETH that accrued to the 0.2 that wasn't topped up. So they've got a great incentive to correct the Stakehouse inventory, because they're actually going to get some earnings of what is happening in the leak bucket. right? So, so from a node operator perspective, the syndicate needs to understand what is going on. So here, fees and MEV LPs, this is just distributing to an ERC20 token, right? So this is like distribution to ERC20 LPs, right? This is just standard LP other way around, LP distribution. But for the node operator side of things, because we're dealing with a Stakehouse protocol, and we want to ensure that the node operators this is distribution to LP, yes, but the LP being the SE, yeah, right. So it is still going to slot, but the LP is the SE, which then gets wrapped, and depending on the strategy that's on top of it, right? And node operators, they will distribute amongst the so you basically node operators will distribute to firstly it's going to distribute to so you have the sum of all of the slot that is registered, sum of slot registered. Then you have for each BLS key you have so you need to factor in, when it comes to the syndicate, you need to factor in BLS key 1 C slot owners, yeah, so you have that, so that goes there. 2, 3 that goes there, and then it then filters through to all the individual owners, and it manages the bucket here as I was talking about here. So anyone who tops up slot that is leaked, it can then claim from the leak bucket. The one thing to bear in mind here is that if we go back to what I was saying about the activation eligibility of POC, now, because you can mint derivatives at this point, but you only start yielding and have the ability to produce blocks from this point, then basically you not fully active validators. You might have liquid tokens, but you are not contributing to the consensus layer, and so cannot be contributing to the syndicate, right? So again, so basically, so there is this 1 plus compute 1 plus, right? Activation exit POC. You, according to the specification, there is there is a distance between eligibility. Yeah, there's a distance between eligibility POC and activation POC, right? So what that means is that according to the spec, I need to find it, but it's about 4 POC between these two minimum. That's like if there is,
that's a max seed lookup, right? That's a max seed lookup.
You're right. So yeah, and what it called not accounting for anything in the queue.
Yeah.
But what it does give us is an indication of like how much time, like basically a validator is inactive for at a minimum before it can contribute to the network. And so if it's not online and working, then cannot, it shouldn't be eligible for shares, for ETH that arrives in the syndicate contract. There needs to be some distance between, being registered inside the syndicate and actually being eligible to receive rewards. So we have this concept of like inactive and active LPs, right? So from like a slot perspective, some of the slot shares registered to the syndicate, some of them may be like active, right? And some of them will be inactive. And inactive can be like you've not reached your eligibility, sorry, you've not reached your activation block, or you've been kicked from the consensus layer, or you're in, you're like leaking, something like that. So the syndicate does a job of like segregating either from information from the stakehouse, which is like a reflection on what's happening on the consensus layer, or through like this activation distance. It knows when the shares need to be active to start like getting pro rata share of any ether arrives in the contract. So but we have this concept of an activation block. So this activation block is basically is a distance between being registered, having the shares registered in the syndicate, and when you can start receiving LPs. And we have so the syndicate will activate proposers. So there is an algorithm for activating the proposers in the syndicate. It tries to follow an approach where this function is called when any state transition is triggered inside the state changing function is called in the it will activate the shares when so when any state changing function is called, and that will bring online the free floating shares and the collateralized shares, and make them active LPs so that they can work as expected. This can also be called by any proposer, and they can once the for epoch is reached, then it allows anybody to call this directly without waiting for a state changing function to be executed. Because the important thing about the way that the algorithm works is it snapshots historical earnings before activating new people. So any ETH that is inside of the contract can that is for like existing activated proposers will not be distributed to anyone that's about to be activated, just from like a fairness perspective. So it allows people to not claim from the syndicate, but always ensure that their historical earnings are being preserved in the contract.
So this is for when there is nothing has been received, right?
When nothing has been received by the contract, so there's like two types of claims. So before the bootstrap claim has taken place, like the first ever claim, then the ETH will actually, any ETH that is received in the contract will just be distributed amongst everyone that's active and about to be activated. That is the bootstrap claim. But equally, any ETH received before anyone is activated will just get distributed to everybody.
So the only difference here is the normal claim distribution with these other two specific scenarios. The snapshot will be taken after activating the proposers, right? And in a normal course of action, a snapshot will be taken before activating any new proposer who's activatable already.
Yes.
Okay.
The historical,
but you can activate this validator anytime that after the for epochs, right? By calling the contract.
Yes. Snapshot is very simple. This does the 50-50 splitting. So any ETH that comes into the contract will be split 50-50, and then if as long as there are active shares, it will be distributed to the free floating, and then it will work out as well for the collateralized slot. how much ETH has been accrued since the last time the contract was executed, and it will distribute it to that.
Mm.
And when it comes to like claiming and distributing to individual collateralized owners, that's taken care of at the time of like users claiming their rewards. So that is so at the time claiming rewards takes place, it will do the job of looking like who's the collateralized slot owner, like what are their balances, and giving them pro rata share of that. But if there is, like I said, so there's any clash, then basically it will accrue to a contract bucket, waiting for anybody to top up the slot.
All right, that's nice.
That'll be withdrawable when the slot takes place. Top up takes place. User comes and tops up, and then it gets accumulated to them, and then that just goes down to zero. The rest of the contract is to do with like registering, unregistering shares. Deregistration will take place when there's violations on the consensus layer. And then the rest is just calculation logic, really, or distributing the rewards. Previewing ETH, like that's claimable, how many is activatable, 50-50. Yep, claiming and staking. And staking, yeah, pretty much it.
All right. Is there any current LSD has a syndicate contract? It has.
Yeah, any of the LSDs deployed have a syndicate contract, yeah. So if you go to you can check here. So if you want to see that original ticker,
I think it's currently.
So yeah. You can actually this one has received
Oh, there's another one. There's like an hour and a half, like activate proposal. Yeah, that's cool.
Yep.
Oh, these are all the tokens ETH is received.
And distributing. Yep. This is a block payment.
Yeah, but then there are payments will also receive to the syndicate without having as a transaction, right? As just an append. Yeah. This is like a vanilla block payment.
Mm-hmm.
So how does from PON it works? Like the LSDs who register with the PON payout pool, they're also going to receive that payouts into the syndicate?
Yeah. They just find the syndicate address and that's it. They just set the fee recipient as that.
in the payout pool, right? So payout pool is a syndicate. Is a payout pool is your MEV payout address. Once you go to PO and PBS, payout pool is your de facto, fee recipient address for the validator. But then that payout pool will actually send that money to the syndicate address. Okay. All right. Nice. So it's just like one layer abstraction about the syndicate. You have LSD sitting on top of Stakehouse, and syndicate is a pool contract, not a registry, right? And then you have this kind of another payout pool. You're coordinating with the all the validators. They get paid there, and that portion of that payment will actually come to a syndicate. And then that actually going to redistribute to the validators in the LSDs. And that will get redistributed to the token holders who has MEV stakers and everything, including those in the giant LP pool or anywhere.
Yeah.
Wow. Okay. That's a lot of accounting, right? That's a lot of layer of accounting that you're building on top. You can have any number of layers, right? Splitting the MEV payouts then.
Totally. Any strategy you want.
Yeah.
Cool. So does that mean that the same contract will act as the syndicate as well as PO and like payout pool as well? I mean, will the same contract perform the functions of payout pool and the syndicate at the same time?
No. PBS has the payout pool, right? So the payout pool has all the all the validators registering with the payout pool, right? And the payout pool receives the money directly. And if the validator is part of the syndicate, if the validator is part of the LSD, the portion of the payout pool that you have the payout, right? 7 days payout per validator, right? That will go to the syndicate contract. Because your validator, as a node operator, your validator registered, you borrowed ETH to set up the validator from the giant pool in the first place, or from direct LSD, right? So your validator has, like other people, has money in it. So whatever the earnings that you receive should go to them too.
No, makes sense. Yeah, no, that's right. So that means that the MEV syndicate will be somehow smoothened out as well. It won't be like for some duration you have no MEV rewards, and for some other duration you have a lot of MEV rewards. It will be like smoothened out when you become a part of a payout pool.
Yeah.
Yeah, that's cool.
That's a consistent MEV payouts. But otherwise you will sometime you will get a jackpot. You will not get a jackpot.
Right. Yeah, that makes sense.
Okay. I think that's a wrap. Thank you, guys.